We're going to pick up our lesson by doing some rearranging and multiplication elimination. And then we'll do a couple word problems just to test that out. So when I look at the first problem, I have x's, y's, and constant, but I have constant x and y. So these are not even set up right to start eliminating. So what I'll do is the top is fine. I have my variables on the left. And that's what I want. So we're just going to copy that. And on the bottom, in my head, my negative 6x, that is correct. It's on the left. So I'm just going to shift that to the front of the problem. But my negative 4y needs to come over. That's going to change it to a positive 4y. So it's no longer here. It's over here, but you have to change it to a positive. And then your 10 is going to need to be subtracted over to the right side. So that's the first thing. You want to make sure you rearrange them correctly. And then it doesn't matter if you pick x, y. I'm going to pick y's. So between 2 and 4, I can just multiply the top row by 2. And that will change this into 4, so I'll have matching coefficients. So I'll have a 6x, a negative 4y, and a 10. And then down below, I have negative 6x, positive 4y, and negative 10. So what we should notice is my x's are going to actually make 0, as well as my y's. So I have nothing left on the left side. But 10 minus 10 is also 0. So we need to recognize this is a true statement. No variables means it's going to be infinite solution if it's true. Okay, number 14. So my m and k are already on the left, so I'll leave the top row alone. And for the bottom row, it looks like my m needs to come across the equals, making it negative. My k's are fine. They need to stay on the left. But my negative 8 needs to come over here, which changes it to a positive 8. So between m's and k's, I think I'll choose to eliminate the m's, which means I need to go through and multiply all of these by 3. So I'm just going to, because I'm a little short on space, I'm going to write my answer down here. So I will get a positive 3m, a positive 3k, and a negative 36. And all I'm going to do is I'm just going to erase this top row here so that doesn't confuse me, since I've already done my multiplication. And then we go through and finish. So it looks like we'll get 5k, and we'll get negative 28. So k is going to be negative 28 fifths. So not an ideal answer, but we have to be able to go ahead and continue the problem and work through it. So I'll probably use the top equation. It's a little easier. M is good, but now k is going to be negative 28 fifths. And that equals negative 12. So I am going to use the LCM trick. I am going to multiply everything by 5. So I will have 5m minus 28 equals negative 60. And then I just kind of work from there. So I'll get negative 32. So m is going to be negative 32 over 5. Okay, so now we're going to put our skills together with a word problem. So it says, at a baseball game, Henry buys 3 hot dogs and a bag of chips for $14. He buys 2 hot dogs and a bag of chips for $10, or his friend does. Determine the cost for hot dogs and chips. So there's your 2 variables. So you're asked to find how much a hot dog costs, so maybe I'll use h for that. So off to the side, you want to write h equals hot dog cost. And we'll use c for chip cost. All right, so you're going to buy 3 hot dogs, so you're going to pay the hot dog price 3 times. Plus, you're also going to buy 1 bag of chips. So 1 bag of chips, pay it once. And your bill for Henry is $14. And then when you look at Scott, Scott's going to buy 2 hot dogs, so he's going to pay the hot dog price twice. He's going to pay the chip cost once, and he's going to spend $10. So it's actually a pretty nice problem because you can just go through and multiply the bottom row by -1. And looks like a hot dog will cost $4. Now you got to find out what a chip costs. So if you use let's say we use the top equation, 3 times $4 each, that would be $12 for hot dogs, plus the cost of the chips for $14. All right, so chips have to cost $2. So hot dogs are $4 each, chips are $2 each. So this time we're going to be talking about, looks like rose bushes and trees. So I'm just going to skip ahead to the question. It says, what were the costs of each? So it's kind of like before. So we use R for rose bush cost. And we'll use T for tree cost. So the first order, we have 13 rose bushes. So you're going to pay the price 13 times. You're also going to buy 4 trees, so you're going to pay the tree cost 4 times. And the first bill is $487. All right, second order, we want 6 rose bushes, plus we want 2 tree orders. And that's going to be $232. So now you should have enough so you can figure it out. I would probably work with T's because I noticed between 4 and 2. 4 works for both of them. So I'm actually going to multiply the bottom row by -2. And you'll see why in a sec if you don't catch it. So I like to just recopy my top row. Then my bottom row will be -12R, -4T, and -464. So hopefully you realize you need to use -2 because otherwise you would have had 2 positive 4s. You can't have that. You don't want a negative, so you have to use a negative. So now my T's will eliminate. I get 1 rose bush. It will cost you, let's see, $23. And then we're going to go back. I'm probably going to use this equation. It seems just a little simpler. Maybe not by much, but that's the one I want to do. So we're going to do 6 times 23 plus 2t equals 232. And then go ahead and pause the video and go ahead and solve that quick. So hopefully you ended up getting that trees cost $47. In the next problem, it says Mr. Smith drove by a farmyard full of chickens and pigs. He happens to notice there's 100 heads and 270 legs. How many chickens and pigs were there? So right off the bat, when we see a problem like this, we need to make sure we remember basic facts. Like chickens, you get 2 legs per chicken and 1 head. And every time you have a pig, you get 4 legs and a head. So you kind of have to remember that if you're counting legs, you get 4 legs per animal or 2 legs per animal. So that'll be kind of important. Obviously, it probably makes sense to use P for pigs. And we use C for number of chickens. So it doesn't look like it, but there's actually 2 equations in here. And the first one is going to be the head equation. So this one is actually pretty easy because you get 1 head per pig, one head per chicken, and there's a total of 100 heads. The next equation is going to be the leg equation. So you have to kind of think, you get 4 legs per pig, and you get 2 legs per chicken, for a total of 270. So go ahead and pause the video, and you pick which letter to eliminate, and then we'll see how you do. I chose to eliminate the P's, and I did so by multiplying the top row by -4. If you wanted to eliminate the C's, maybe you did -2. Either way, it should work out to the point where you get 35 pigs and 65 chickens. And if you just stick both of those in, it does check out with each equation.